Okay, Calc differential equations, worksheet 1, problems 9 through 15. Problem 9, we're going to separate the variables. So we are going to bring dx over to the other side by multiplying both sides by dx. So these cancel. I'm left with dy on the left. I'm left with 2x plus 1 on the right. Now we integrate. Remember, there's still a 1 out front here. The antiderivative of 1 on the left is just y. The antiderivative of 2x is 2x to the second over 2. And the antiderivative of 1 is x plus c on the right with the x's. Simplify that. Y is equal to, those are going to cancel, x squared plus x plus c. Now we're going to bring in this point. At this point, we can find the specific solution. Oops, excuse me. So we are going to plug in our point, 0, 0. The x is 0, the y is 0, and we're going to find c. So y is equal to 0, 0 squared plus 0 plus c. So easy enough, c is equal to 0. Oops. Okay, so this is my general solution. And if I plug in c, y is equal to x squared plus x plus 0. This is my specific solution. Okay, number 10. Before we can separate the variables, we have to move this term over to the right. So we are simply going to add x over y to both sides. Now we're left with dy dx on the left, and we're left with x over y on the right. Now you can see it's much easier to separate the variables. Dx has to move over to the right, so I'm going to multiply both sides by dx. So these are going to cancel. I have dy on the right, on the left. On the right, I have x dy on top of my fraction. I have y on the bottom. Now I simply need to move this y over to the left. And again, because it's in the denominator, I'm going to multiply both sides by y. So y dy is on the left. These are going to cancel. X dx is on the right. Now I integrate both sides. All right, the antiderivative of y is y to the second over 2. So we write it as 1/2 y squared. On the right, same thing. The antiderivative of x is x squared over 2. We write it as 1/2 x squared and then plus c. This is our general solution. Okay, now we're going to plug in our point. So now we plug in 0, -2. And that's going to help us find c. Alright, this is my x and this is my y. So 1/2 times -2 squared is equal to 1/2 times 0 squared plus c. Alright, the 1/2 comes down. When I square -2, I get 4. This is just 0 plus c. Alright, half of 4 on the left is 2, and 0 plus c is c. So my specific solution is 1/2 y squared is equal to, typo, 1/2 x squared minus 2, or plus 2, plus 2. Okay, there you go. There is our specific differential equation. Specific solution. Okay, number 11, moving right along. Okay, the only thing that we have to do to separate the variables here is to multiply both sides by dx. We need to move that dx over. So these cancel. dy is equal to e to the x plus 1 dx. Now I integrate both sides. Remember, there's still a 1 here. So the antiderivative of 1 on the left is y. The antiderivative of e to the x is e to the x. And the antiderivative of 1 is just 1x to the first over 1. So plus x plus c. All right, there is our general solution. Now we plug in our point. 0 is our x, 2 is our y, to find c. So 2 is equal to e to the 0 plus 0 plus c. The 2 comes down. This, anything to the 0 power, is equal to 1 plus 0 plus c. So 2 is equal to 1 plus c, and then I subtract 1 from both sides. So I get c is equal to 1. So this is my general solution. If I plug in this c value right here, that gives me my specific solution. So y is equal to e to the x plus 1. And there is my specific solution. All right, not too bad. All right, number 12. Okay, to separate the variables here, we have to move this dx to the right. So we multiply by dx over 1. We cancel here, so dy is equal to negative 2y dx. And now I need to move this y to the left, and since it's in the numerator, I'm going to divide both sides by y. All right, on the left, this is a 1 out front, so I'm going to pull this fraction out front. I'm going to rewrite that as 1 over y dy, so that I know how to take the antiderivative on this side. On the right, the y's cancel, and I simply have negative 2 dx. All right, now I integrate, take the antiderivatives. The antiderivative of 1 over y, that is ln, absolute value of y. On the right, the antiderivative of negative 2 is simply negative 2x to the first over 1. So negative 2x plus c. All right, now remember, I can't have ln here. So now we exponentiate. We make e the base on both sides. Again, that is called exponentiating. Okay, again, that allows us to cancel this out. So I'm going to go up here. On the left, I'm left with the absolute value of y. On the right, remember, I have to rewrite this side because I can't have c in my exponent. So I pull that out using exponents. So I have e to the negative 2x times e to the c. This right here, this right side is equivalent to this, because when I'm multiplying two exponents here and here that have the same base, I add. Okay, I'm going to rewrite this. The absolute value of y is just y. This right here, I'm going to highlight it. This is my c value. All right, so I'm just going to put that in front. This is the same as c. So c times e to the negative 2x. Now I can plug in my point. 0, 2. 0 is my x, 2 is my y. So 2 is equal to c times e to the negative 2 times 0. And now I can solve for c. So 2 is equal to c times 1. 2 times 0 is 0. Anything to the 0 power is 1. So c times 1 on the right gives me c. So c is equal to 2. Okay, so this right here, that is my general solution. And my specific solution would be 2e to the negative 2x. This is my specific solution. And I can't spell, but you get the gist of it. specific. There we go. Okay, all right, halfway done. Yep, okay. Now we're just going back to finding the general solution. So we separate and integrate. On the left, dx has to move over to the right. So dy, times dx, both sides. dy is equal to negative 2 dx. Integrate, put the big elongated s. There's a 1 out front. The antiderivative of 1 is y. On the right, the antiderivative of negative 2 is negative 2x plus c. Done. General solution. 14. To separate the variables here, we need to move over the dx. That's the first thing that we have to do. So we're going to multiply this side by dx over 1 and multiply this side by dx. These cancel. I have x cubed dy is equal to 2 dx. Now I need to move over this x cubed. So I need to divide both sides by x cubed. So these cancel. On the left, I have dy. On the right, I'm going to pull this apart right here. Okay, I'm going to leave the 2 out front, but I'm going to write the x to the third in the denominator. I'm going to write it like this. 1 over x cubed, and then dx. All right, now I still don't know how to take the antiderivative of this fraction, but I can rewrite this. So I'm going to leave the left-hand side alone. I'm going to leave the 2 alone, but I'm going to rewrite this. I'm going to move the x to the third up to the numerator, so the 3 becomes negative. So that's going to give me 2x to the negative third dx. The reason I do that is because then I know how to take the antiderivative over here. I've got it down to a power rule. Alright, so now I am ready to integrate both sides. There's a 1 here, remember. So on the left, the antiderivative of 1 is y. On the right, the 2 comes along for the ride. When I use the power rule on x to the negative 3, I add 1 to the exponent. So I have x to the negative 2 all over negative 2 plus c. Alright, so now let's simplify that. The 2's right here cancel, but don't forget I still have a negative 1 out front. So y, so y is equal to negative x to the negative 2 plus c. And let's practice getting rid of negative exponents. That's all over 1. I can move that guy downstairs. So I can write it as negative 1 over x to the positive 2 plus c. And that is my final answer. Yes, I have to know how to rewrite negative exponents because I can't solve for c if I have a negative exponent. Alright, almost done. 15. In order to separate the variables, I have to move this term over to the right. So I'm simply going to add 2e to the x to both sides. So on the left I still have dy dx, but on the right I have 2e to the x. Now the next thing to move over is this dx. So now I multiply both sides by dx over 1. So on the left these cancel. I have dy. On the right I have 2e to the x dx. Alright. I integrate both sides. There's still a 1 here. The antiderivative on the left is y. On the right, this 2 comes along for the ride. The antiderivative of e to the x, our favorite easy one, is e to the x plus c. Alright, and now finally, number 16. Okay, we are going to separate the variables. We're going to multiply both sides by dx. This dx has to move over. Dx over 1 times dx on the right. These cancel. dy is equal to negative 0.2y dx. Alright, now I have to move over the y. So I'm going to divide both sides by y. Okay, on the left, remember, we're going to rewrite this. There's a 1 out front, So I'm going to pull this out front so I know how to take the antiderivative on the left. So I have 1 over y dy. On the right, these cancel. I have negative 0.2 dx. Now I'm ready to integrate. Don't forget to put up your big elongated s's. All right, the antiderivative of 1 over y is ln, absolute value of y. On the right, the antiderivative of negative 0.2 is just negative 0.2x plus c. Okay, to get rid of the ln, remember we exponentiate. We make e the base. Put a big fat e there. Exponentiate. It's kind of a fun word. Okay, all right, this cancels here. Absolute value of y is left on the left. On the right, remember we have to rewrite this to get c out of the exponent. So it looks like this, e to the negative 0.2x times e to the c. This is our c right here. Okay, so we're going to zoom up here. The absolute value of y is y. On the right, I'm going to put c in the front. I can either write it as e to the c times e to the negative 0.2x, or you can just call it c. Y is equal to c times e to the negative 0.2x. Either of those is acceptable. All right, pre-calc. Hope you're doing okay with differential equations. Take care. Miss you.